Water Potential by Cameron, Madison, and Hope. The formula for water potential is psi equals solute potential plus pressure potential. To find the solute potential, you take negative I CRT. I is the ionization constant, C is the concentration, R is the pressure constant, and T is temperature. Water will always move from a high to low concentration.
Here's an example of water potential. Here you have an arsenic solution in a beaker of distilled water, and if it's an open beaker, it'll always have a zero pressure potential, as seen over here. So water will go into the cell.
Some of the vocab for this unit includes hypertonic, which means a solution with a greater concentration outside of the cell than inside. Hypotonic is the opposite, a solution with greater concentration inside of the cell than outside the cell. Isotonic simply means a solution with a concentration of solute equivalent inside and outside of the cell.
Here's a water potential problem. An animal cell is in a beaker of pure water. The cell is filled with 0.4 moles of NaCl at a temperature of 27 degrees Celsius. Which way will the water move? So if you see, you have 19.9 bars, and so that would be for the cell, and out here it would be a zero pressure potential, so water will move inside of the cell. A plant cell containing 0.6 moles of solution of sucrose is placed in pure water in an open beaker with a temperature of 30 degrees Celsius. Which way will the H2O move? So you also use the water potential and solute potential problems to solve it, and water again will move inside of the cell. For sample 3, the value of psi in a plant is negative 4.9 bars. If you place the cell in a 0.1 mole solution of glucose in an open beaker at 17 degrees Celsius, what is psi of the solution, and which way will the water flow? So again, you have the cell inside of an open beaker, and here's the math. So it shows that it will move from a high to low concentration, so water will move inside of the cell. For the last problem, a plant cell filled with 0.4 moles of solution of NaCl was placed in an open beaker filled with 0.2 moles of solution of sucrose at 20 degrees Celsius. Which way will water move? And so it's just like the others, but you have to solve the solute potential for both one. So water will move inside of the cell from high to low concentration.
Plant cells. In a hypotonic solution, the cell will absorb the water and maintain its structure due to the presence of the cell wall. Instead, in an animal cell, in a hypotonic solution, the cell will absorb the water but will burst.
Thank you for watching our water potential video.